Here we are back again with our math. But unfortunately the number line here is broken. So if he ever happens to cross over to 3, he would fall and die. In this new setup, we again ask ourselves the same question. What is the chance that the guy will be at 1 after exactly 13 steps? As usual, it will help to think in terms of graphs. We want to count the number of paths from the origin to this point 13, 1. But during this time, we must not hit this horizontal line through 3. Thus, we cannot allow a path like this, because the moment the guy first hits 3, he will fall and die. So how should we proceed? I pause here to give you a chance to think. We already know how to count all the paths from this point to this point. So if we can count the paths that violate our condition, that is hit 3 somewhere, then we can find the required answer by subtraction. So consider the set of all paths A that will go from 0, 0 to 13, hitting 3 somewhere in between at least once. Then take one typical path in this set A, like the one that I have already shown here. Now see where this path first hits 3. Consider the portion of the path up to that point, the part that I have shown in darker color. To appreciate the next step, imagine this graph as floating in 3D space. Now take this dark part and reflect it along the horizontal line. This gives you a new path. The final point is still the same, 13, 1, but the starting point is now 0, 6 instead of the origin. Notice that this reflection of the part up to the first meeting with 3 establishes a bijection between our set A and the set of all paths from 0, 6 to 13, 1. We have seen how a path in A turns into a path from 0, 6 to 13, 1 after reflection. Conversely, if we start with a path from here to here, then that path is bound to cross this horizontal line somewhere or other, because the two endpoints are on different sides of the line. Now if we apply our reflection of its initial part, then we shall return to a path in our set A. Thus we can move between the two paths in a bijective way. So our set A has the same size as the number of paths from 0, 6 to 13, 1. We already know that there are n 13, 5 many such paths. So we get that size of A must also be n 13, 5. This trick is called the reflection principle. Now it is time for you to solve some problems. Try to use reflection principle to answer these questions. Don't forget to draw a graph in each case.